Alrighty. So we are going to be talking about absolute value limits, and then we'll talk about infinite limits in the next part. But as a reminder, back in Math 3, we talked about absolute value and how it could be split up into two linear parts. I could say that negative x is less than or equal to 0, and then x is greater than 0. I can flip-flop where my equal to sign is, so it doesn't literally have to be here. It could be here. It doesn't really matter. But what we're going to do here is just split it up into two linear parts. We have the left side and the right side. So looking at this right here, I'm only focusing on the left side because I'm approaching t from the left. Now, let's think about what the absolute value of x minus 2 looks like. That right here looks like this right here. If I'm approaching it from the left side, I'm only looking at this part, aka my negative part, so I have a negative slope, which means I have the limit as x approaches t from the left, and that linear function right here is negative x minus 2. I can cancel that out, so now I'm just left with negative 1, which means that my answer is, guess what, negative 1. All right, same thing for this one right here. I'm going to split it up into two parts. So I have the limit as x approaches t from the left. And if I were to do t from the left from this exact same thing, that's going to give me my negative counterpart. And that's going to give me negative 4, because I'm going to plug in 2 here. So 2 plus 2 is 4. 4 divided by 1 is negative 4. Then I have 2 from the right. Now, if it's the right side, I have a regular positive slope. So that's just going to be x minus 2. And if I were to use direct substitution, that's going to give me 4. Plot twist, negative 4 is not equal to 4, which means that my limit does not exist. Now, you'll realize pretty quickly if I have a two-sided limit like these right here, like this one, probably this one too, it's not going to exist because it has to be split up into two parts. So, as an example, we're going to look at x squared minus 4. And we're going to look at the absolute value of x minus 2 here. And if I were to look at this, you'll notice that, hey, it's being split up into two parts. I have my left side and I have my right side. And of course, since they don't match up, my limit doesn't exist. Now here I have the limit as x approaches 3 of 1 over the absolute value of x minus 3. Oops. So that's going to give me 3 from the left, and then 3 from the right. All right. Now, what I'm going to do is think about this two ways. The first way is sketching what 1 over x minus 3 is and what 1 over negative x minus 3 is. If I were to sketch this right here, 1 over negative x minus 3 is going to look something like this. And if I'm looking at 3 from the left, I'm going to have negative infinity. Now, same thing here. If I were to do 1 over x minus 3, that's going to look something like this. But I'm approaching it from the right, so that's also going to be positive infinity, which means that my limit here is going to be positive infinity. Now, that's my first way, aka just graphing it and visualizing it by using a graph. Now, what you can do is pick an arbitrary small value that's from the left of 3 and that's from the right of 3. So if I pick something like 2.99999999999, I'm going to get 1 over some negative 0.00000001 or something like that. And essentially, if I do 1 over some very, very, very tiny number, that's going to give me infinity, especially since I have a negative and a negative. Likewise, if I did 3.00000001 or something like that, I'm going to get 1 over 0.00000001, and that's going to be 1 over some very, very, very small number, and that's going to give me infinity there. So because both of them gave me infinity algebraically by plugging in an arbitrary small value from the left and from the right, I know that my limit here is infinity. These two right here does not exist. We obviously know why based off of this right here. If you want to do it, then look at the left side and the right side and see that they do not exist. So anytime you have something from the left side and the right side like this, your limit is going to exist. It's just, what is it? Well, I don't know. So like this one right here, I know that my limit is going to exist. And since this is -4 from the right, I'm just going to remove the absolute value since it's my positive part. And here, that's just going to give me 5. Likewise here, since this is 0 from the right, I'm just going to remove the absolute value, and that's just going to give me 1. Crazy. Here, since I have 9 from the left, I got to make sure that my absolute value is the negative counterpart. So I'm going to have my negative right here for this right here. Cancel that out, and then plug in 9 using direct substitution. That's going to give me -9. Likewise, this is -4 from the left, but notice how I don't have any absolute value signs. So honestly, I'm just going to go ahead and use, let's say, direct substitution and see what happens. Because I'm going to get 16 minus -4 square. -4 minus 4, I get 0 over -8. That's just going to give me 0. Notice how this is not indeterminate because my denominator is actually a number. So here, this was just a simple direct substitution, a simple plug and chug. Now, can you simplify the 16 minus x squared? Yeah. You could say 4 minus x, 4 plus x over x minus 4. Let's go ahead and factor out a negative from here so that I have negative 4 minus x. So then you'll notice that this will cancel out. This will cancel out. So now I'm left with the limit as x approaches -4 from the left of -4 plus x. And notice how this right here is still a continuous function because it's a continuous linear function. So if I were to plug in -4, I'm still going to get 0 anyways. But obviously, you probably want to use direct substitution first because it's going to be the easiest if you can, obviously. All right, in the next video, we'll talk about infinite limits, aka the vertical and horizontal asymptotes.